Hola, we're going to look at drawing graphs without using a table of values. So drawing it from the gradient and from the y-intercept. So y equals to mx plus c is the standard equation of a straight line. The number before our x is going to be our gradient. So that's how steep it is, or every time we go 1 unit to the right, how far we go up or down. And this plus c is going to be our y-intercept. So where we cross the y-axis. This one in the middle here. So, in this case we've got plus 1. So we are crossing the y-axis at 1 on the y. That would be a coordinate 0, 1. And then we have a gradient of 2. So if I plot my coordinate here, I'm going to do it in a different colour actually. So I'm crossing the y-axis at 1, so I'm going to draw my first coordinate there. Because I've got a gradient of 2, every time I go 1 square across, I'm going to go 2 squares up. So then I plot my next coordinate there. Then I'm going to go 1 square across and 2 squares up. So I plot a coordinate there. Generally you can stop after 3, but I'm going to do a few more just to prove the point. 1 across and 2 up. And if we kind of go backwards on the graph, so if we start going down left, if we go 1 left, instead of going right and up, we would do the opposite. So if we go left, we'll go down. So left 1, down 2. And then left 1, down 2. And left 1, down 2. And left 1, down 2. You know you're on the right lines if you stick your ruler between them. And it's a nice straight line like so. So in a different colour. When you draw your line through it, always just cover the whole of your graph, of your axes. Don't just go between the 3 or 4 points you've plotted. Cover the whole graph. So this line is y equals 2x plus 1. Here we've got y equals x minus 2. So we've got a bit of a secret 1 here. So we know we're going to cross the y-axis at the coordinate 0 minus 2. It's really important you keep the sign that's with it and not just put it at 2 because it's actually at minus 2. And then we've got a gradient of 1. So my first point is going to be down here at minus 2 on the y-axis. Gradient of 1 means if I go 1 square to the right, I'm going to go 1 square up. So 1 square to the right, 1 square up, and I plot my point here. 1 square to the right, I'm going 1 square up. I plot my point there, 1 square to the right, 1 square up, and so on. And then if I start moving left, 1 square to the left, 1 square down this time. Stick your ruler between them points when you think you've got a decent amount of coordinates on your graph. Generally 3 I always say is fine, because 2 is you can't tell if it's a straight line or not if you've made a mistake. 3 you can spot if you've made a mistake because them 3 points should all fall in a line. Obviously the more points you do, the more certain you are you're correct, but 3 or 4 is always sufficient. Go all the way through your graph and that would be our line x minus 2. Okay, looking here at y equals minus 3x plus 2. So we're going to cross our y-axis at the point positive 2, because that's positive 2 there. And then we've got a gradient this time of minus 3. Important to keep this sign with it. So that means every time we go 1 right, we go 3 down, because a negative gradient goes down, a positive gradient goes up. So 1 to the right and 1, 2, 3 down. 1 to the right and 1, 2, 3 down. 1 to the right and 1, 2, 3 down. So I've got enough points here to go, but if we were to go backwards, so if we're going to the left this time, we're going to do the opposite. So instead of going 3 down, I'm going to go 1 to the left and 1, 2, 3 up. So grab your ruler, line it up as good as you can between the points. I'm going to say that will be fine for me. We'll do one more tick, there we go. And all the way through your graph. And we can see my points are forming a nice straight line. That's how I know I've got it correct. Different example. So y equals a half x plus 3. We should be figuring out at this point, then we're going to go through here because it's plus 3. 3 on the y-axis. When we've got a gradient of a half, that means for every 1 I go to the right, I go a half up. Sometimes it's quite hard to plot points at half a square, or half a coordinate. So actually, I can say that, well, that's the same as if I go 2 to the right, I'm going 1 up. Because if you just think about that, going 1 to the right is half, so 2 to the right must be 1. I like to just kind of do it in this sense, so I'm going to go with this pattern. 2 to the right and 1 up. 2 to the right and 1 up. 2 to the right and 1 up. A gradient of a half, or gradient of a fraction less than 1, it should be quite a shallow slope, because a gradient of 1 would go up in a something like this. You can see from our second example we did, so it should be shallower than that. And then going in reverse, if we go to the left, it would be 2 to the left and 1 down. 2 to the left and 1 down. So grab your ruler when you've got enough points for that. Oops. Sorry. Scroll tool is the same for zooming in and out and for moving the ruler. Get them between there. I'm going to go in a different colour all the way through your graph. Every single time. You can lose marks for it otherwise, and you wouldn't be mathematically correct, which is more important. Okay. What's different about this one? Well, for a start, we've always had something that looks like y equals. We've always had y equals. This one is not y equals. Well, why don't we make it x plus y equals 1? So to get y on its own, I just need to take y from both sides. So I'm going to get y equals to 1 subtract x. It looks a little bit different, but you can write it like this and it might seem to make a bit more sense for you now. All I've done is I've taken the minus x, put it on the left, and the positive 1 and put it on the right. You can plot it from both, but looking at our y equals to mx plus c, we can see that this starts to link up better. So we know that we're crossing at positive 1, so my first point is going to be here, and we know we've got a gradient of -1. Remember, there's a sneaky little 1 here when we don't write a number next to our x's. So that means every time we go 1 to the right, we go 1 down. Ooh. Oh, I'm doing them terrible today. I will leave it. 1 to the right, 1 down. So 1 to the right, 1 down. Next plot here. 1 to the right, 1 down. 1 to the right, 1 down. And you might be able to start seeing a pattern with these straight lines. You should do. They're always going in a straight line, so they always follow a nice little pattern. So I can see it's going to turn out like this. So as I spin my rule around, perfect. I'll go in green this time. I've got a nice colour for the finale, so hang around for that. There we go. Bit of a thicker line, but that would be what our line looks like. So the important thing is to rearrange it to be y equals. And then final one here. So it's not in the form we want. We want it in the form y equals to mx plus c. But right now, we've got that. Maybe you want to give it a pause, see if you can rearrange this one, and then come back once you've done it and see if you get the same as I did. But I would add 4x to both sides to start with, because I want to get rid of this little section, because that's kind of interfering with it being y on its own. So 2y equals to 6 plus 4x. And then I just want y. We've got the y's over here and nothing else, but this 2 is not letting it look exactly like that. So I want to divide by 2. Y, 6 divided by 2 is 3, 4x divided by 2 is 2x. Again, I like to rewrite with my x's at the front because it looks more familiar to me of how I expect an equation of a line to look. So, well done if you got that with your rearrangement. So y equals 2x plus 3. We should be able to see that the first point is going to be here. Here we go, that's the fancy colour you've all been waiting for. Because of our intercept there. We've got a gradient of 2. So that means when I go 1 to the right, I go 2 up. So 1 to the right, 2 up. It's going to be here at 2, 1, 5. 1 to the right, 2 up. And if I start going in reverse from here, if I go 1 to the left, I'd be going 2 down. Opposite of going 2 up. And I can fill in a few more, not that you need to or anything. And then, let's see what this colour is. Oh, that's quite nice. Big finale. Stick a ruler through it. And Bob's your uncle. We've plotted the line 2y minus 4x equals 6. We could also say that that's y equals 2x plus 3. This skill is really, really important for what we are going to be looking at next, which is going to be solving some inequalities with graphs, and we need to be able to plot lines and rearrange things quite easily to enable us to do that without having too many problems. So there'll be an exercise up for you, and come back to this video throughout it in case you get stuck at any stages.